Hello, everybody, and welcome to another episode of Connect Conversations. Today's conversation is all about important measures for a vibration program, and it is brought to you as a part of Mobius Connect's ongoing YouTube series, Connect Conversations. I'm Kim Fugger, the manager of Mobius Connect, and I will be your moderator for today's session. First, I'd like to take a moment to introduce our host and guests of the Connect Conversations series. As our hosts, global reliability improvement experts Doug Plucknett and Ron Moore, and we have special guest Andy Page joining us today. Hi guys, how are you?
Great.
Good, Kim. How are you?
Good. Well, before I pass the microphone officially over to you guys, I just want to encourage our audience here today to submit any questions that you have during the chat panel here of your Zoom platform. And we will have Doug, Ron, and Andy answer all of your questions live here today. Don't feel like you'll get called out unless you specifically want to, but today is all about a conversation. So at any time that you have any questions, please go ahead and type them in. All right, guys, I'm going to pass it over to you.
Okay, thank you. Well, the first thing I want to do is to say thank you for joining us, whoever you are out there. Appreciate you being here. And it's a bit of a treat today. We've got Andy Page, a vibration analysis expert, among other things. Andy, you have any other expertise besides vibration? Or?
Oh, probably not.
Okay. All right. Well, I'm sure you do, but we're going to talk about vibration today, which is, I reckon, your forte. Before we did that, I want to just make a few comments about, random failure patterns. And I want to start out with a war story, literally a war story. Okay. It's about the B-24 bombers in World War II. Those bombers were set up on a schedule to do intrusive maintenance. Every 50 flight hours, they were going to go in and overhaul and replace and all that sort of thing. And they started tracking this data. And immediately after all that intrusive work, they would have something on the order of 40 repair work orders. And then the next week it would be 30. And the next week it would be 20. And the next week it would be 10. And the next week it would be 5. And then they'd start over. And right after the intrusive work, there would be 50, then 40, then 30, then 20, then 10, and they'd do it over. And if you just look at the data, you go, well, that looks stupid. Why would you do that? And it's called the Waddington effect now because he characterized it, and so he got to name it. Anyways, the point was they were doing unnecessary work associated with the aircraft, and they were disturbing an otherwise stable system. And it was actually inducing more defects and failures than it otherwise would have if they just, in that instance, let it run to failure. Well, you can't do that on an aircraft. Certainly you don't want to, it's catastrophic. And the broader point here, though, that we're going to get into is that if you look at the RCM charts, from Nolan and Heap, John Mowbry's book, Doug's book, what you find is that almost all the failure patterns, bathtub, infant mortality, and so on, almost all of them have in their time period a random or a constant conditional probability of failure. Well, what does that mean? Well, that means the probability of any one machine failing is the same as the probability of any other machine failing. But what that turns out to be, when you actually look at the data, is a random failure pattern. So the question is, if most machines, something on the order of 90%, have a random failure pattern, how do you manage that? Well, one thing you don't do is time-based replacement, because you're restarting the risk, you're doing unnecessary work, and you're restarting the risk of infant mortality. And that's what they found with those B-24 bombers. So we've known this now for 75 years, and yet a lot of folks just feel compelled to continue to do that sort of thing. So we're going to let Andy talk a little bit about vibration analysis and the key kinds of practices and issues you need to address. And one other point I wanted to make before I kind of turn it over to him is it's really important. It's absolutely essential in my view that you tie your vibration analysis program, or for that matter, your condition monitoring program, into your work management, your planning and scheduling, so that you act on the findings of your condition monitoring program. So that's probably enough said to do the introduction. Doug, do you have anything to add before we hand it to Andy?
No, I'm just happy that we brought the big guns in here today to talk about vibration analysis and some of the issues that companies struggle with in doing this and getting it done, and not only identifying it, but then the planning, scheduling piece of it, and the importance of understanding that. So with that said, I'm going to let Andy have the floor here. He is our expert.
Well, thank you guys. I appreciate that kind introduction. And Ron, thank you for that story. I think that sets us well to jump into the deep end of the pool, as they say. You know, if you think about the pattern F stuff that you were just talking about, right? The infant mortality failures that come after we touch things with tools. I think it's not just, you know, taking things apart and seeing what's wrong and putting it back together. It's also, you know, we've done a repair of some other work, and as we put the machine back together, you know, we either did something wrong or failed to do something right. And so it's not just intrusive PMs that create this, it's also corrective work that in and of itself may have been righteous work, but because we either did something wrong or failed to do something right, we introduced these new failure modes. I'll give you a great example of this. When I worked in mining, you know, I was at a particular mine site one day, and a couple of mechanics had replaced the coupling on a particularly important pump in the mine. And they knew I was on site, so they said, hey, you know, come over and check this thing. We think it's good. If you think it's good, then, you know, we'll give it back to operations and we'll walk away. So I go over to this pump and we're collecting vibration data on it, and we find that, let me just say, the vibration data indicated a potential rotor bar problem. Now, we had just checked this thing like 3 weeks earlier. It had been on a monitoring program for a couple of years now. There was never any indication of an electrical problem or a rotor bar problem in the motor. However, I did know they just replaced the coupling, which means they had disturbed the alignment of the motor. They had loosened all the bolts, turned it, you know, 60 degrees or so, whatever it took to replace the motor side coupling hub, put it back in place, you know, put their laser alignment heads on it, ran through the process, and, you know, got it back into proper alignment, and figured they were good. So I said, okay, wait a minute, we've got a really high chance of soft foot on the motor. And for those of you who are not familiar with it, it's a mechanical condition where you failed to put the correct amount of shims under a particular foot. You've torqued that bolt to the particular torque specs it was supposed to be, and have thereby put the frame of the motor in a little bit of a twist. And it only takes a tiny amount of twist for the electrical fields in the motor to recognize a variation and start introducing new vibration into the pattern. So I said, guys, did you do a soft foot check? Oh yeah, we absolutely did. Followed the steps on the laser alignment tool, we did. And I said, well, I think we've got a soft foot problem. I go, why don't we check it? So you can put your vibration meter into constant monitoring mode, where you can watch the vibration real time. And we loosened one motor foot, one motor bolt, nothing happened, so we tightened it back up. We loosened the next motor bolt, nothing happened, tightened it back up. When we loosened the third motor bolt, all of the electrical vibration we saw fell down to nothing, right where it was supposed to be. And I said, okay, guys, I think we got it here. Tighten that back up. They tightened it back up. That electrical vibration came right back up where it had been just a moment ago. And I said, okay, loosen it up. They loosened it up and it fell right back down. And they did their measurements, threw another 6 thousandths of shims under there, tightened the bolt back to where it was supposed to be. Vibration didn't change, stayed right where it was supposed to be. So these guys had thought they had went through the proper process. But I think in the mix of, let's say, Ron, you and I are working on it, you're doing some parts, I'm doing some parts, we're doing some parts together. There was a foot that got missed in the soft foot check. And as a result, there was some very high frequency vibration creating 20 or 30 G's of force in the time waveform. Left to its own devices, that would have destroyed that bearing in less than a month. And we would have sent that back to the motor shop and claimed electrical problems. And of course, that would have started a big, brouhaha between us and the electrical shop. All it was infant mortality, right? A pattern F failure mode, and a post-maintenance inspection caught it. We fixed it, no problem.
Yeah. One question I have for you, just a off the cuff question. My impression is that, if you use too many shims, you're going to get an accordion effect.
Yeah.
And so is there any guidance on, number or size of shims that you ought to limit yourself to minimize that risk?
The guys who are into such things talk about 3 or 4, no more than 4.
Okay.
They like 3 better. The fewer the better is the rule.
Yeah.
But 3 seems to be an acceptable number for most people. When you get 5 or 6, you're going to start to get that, right? Because even when you tighten it down, you're going to have there's this potential, because none of the feet are really milled flat, and
right.
Therein lies the problem. The gap looks good on this corner of the foot, but when I move to one of the other 3 corners, it looks funny, right? So we call it the accordion effect, but well and truly, it's all we really got is a feet that's not flat. Yeah. And when the feet's not flat, it depending on kind of where the bolt is in the hole, when you tighten it, is kind of which corner touches first, if you will.
Yeah.
So
one of the other things I've encountered in working with different places is some places will cut corners and they'll buy shim stock, and so you see them cutting them with 10 snips or whatever. And they don't realize that creates a bit of a lip or an edge. Yep. That when you're tightening down, that can cause you fits as well. That's one of the things I try to recommend. I say, hey, it's worth it to go out and buy those pre-stamped shims, right, in the set. They are well worth the price.
Well, they call those that when you cut them like that, they call them step shims, right?
Yeah.
And people get quite artistic in stepping all the way around the perimeter, the outer perimeter of the bolt, trying to close up all of those gaps, and they wind up, instead of 3 shims, they 5 or 6 of various shapes and sizes. And it seems like a good idea until the guy that did it takes it apart and has to redo it, and then they don't have the same artistic level, right?
We had a question here, guys. Is there some kind of standard for shims, no more than 3 or 4? We've answered that. Materials, widths, and so on. Any other standards that you want to articulate?
Stainless steel only, right? And it needs to be larger than the foot. If it's not larger than the foot, then we're back to the same problem.
Okay. All right. One of the things that, Art Crawford, you guys probably remember Art, super duper guy, one of the best guys I've ever come across, both technically and personally. Yeah. But he made a comment on several occasions, but I certainly remember one where he said 80 to 90% of vibration problems are associated with unbalance and misalignment. I just wanted to ask if that's consistent with your experience, or, what would your observation be about that? Because if you could resolve that, I mean, golly, it solves a lot of problems.
I would say that the data that I've been associated with that's not exactly true, but it's pretty close.
Okay.
It's definitely misalignment, and the fitment of the bearing, that kind of thing. Imbalance is up there for sure in the top 4, top 5, but lubrication is a huge one, right?
Yeah.
Improper lubrication, wrong lubrication, not enough, too much, wrong type, wrong frequency,
Yeah.
contamination. I mean, lubrication is huge. And if you want to just add lubrication to that list and call that the top 3, I'd be pretty satisfied.
Okay. Well,
We can tell you from doing hundreds of RCMs that there are plenty of companies out there that think that they should be solving their lubrication issues with vibration analysis. And I tell them, no, you kind of got that backwards, right? You don't want vibration to tell you that you got lube issues. It's way too late by then, right?
Yeah.
well, we've known for years though, and I'm assuming it's still true because I haven't checked the data in 3 or 4 years at this point. But brand new oil is not so great crap. It's a technical term, but notionally nominally it's about ISO grade 20, which is about 10,000 wear particles per milliliter that are 5 micron or bigger. And so if you don't tend to that and filter your lubes and make sure that your machines are clean so you don't contaminate the oil, and make sure things are color coded so you put the right lube in, and the list is long, but it just requires a lot of attention to detail.
Yeah.
So is that still about the same rule of thumb?
I haven't checked it in a little bit, but it wouldn't surprise me if it's the same, because I've been to where they blend the oils and fill the barrels, and when they bring the old barrels in, let's just say that the cleaning of the old barrels before they refill them is not what you would think it should be. And
Andy, vibration has changed a lot in my lifetime in manufacturing. When this first started out, it was always guys going around and taking the readings, and today it's kind of moved way towards remote monitoring or continuous monitoring. Can you speak to those? What's going on there?
Oh, absolutely. Yeah. So we got to be careful on this particular conversation, because when we think about continuous monitoring or remote monitoring, there's really 2 different classes. The only option we had for a long time was a standard sensor that was permanently wired, and that was extremely expensive, but it also gave us the same exact quality of data that we got as we walked around and did our walk around routes. What we're seeing now is a whole bunch of, we'll just call them discount sensors that are of a different technology. They're not piezoelectric like the ones that we walk around with, but they're substantially cheaper than the ones we walk around with. So I can get more things onto a continuous vibration, or we'll just say remote monitoring kind of model, but the quality of data that they are able to ship back to us is far inferior to the stuff that you get from a piezoelectric sensor. All right, so you're limited on bandwidth, so you're limited on the maximum frequency that you can collect and the resolution of data that you get from it. So in short, the expensive piezoelectric stuff gives you the same quality data. The substantially cheaper sensor doesn't give you near the quality of data, which means on the higher frequency stuff like gear faults, bearing faults, lubrication issues, you won't catch them with that near as early as you would with a piezoelectric sensor. But there is some advantage to continuously monitoring, even though you're getting kind of lower frequency data. So if something does come unwelded, as they say, come unbolted or broken, or we get an imbalance or some source of misalignment, I mean, you'll see it immediately, very, very easily. So that the low frequency stuff's easy. It's the higher frequency stuff and the resolution of the data for kind of the same level of analytics we would normally get with a piezoelectric sensor.
Yeah. Now, Another,
And this is.
go
I
ahead,
can
Doug.
tell
I
you-
had another question, but you go
Yeah,
ahead.
I get a lot of questions around, is there a, a book or a pamphlet or something that I can read, that I can learn the basics about vibration enough to make good decisions. And you know, I tell people, look, I'm not an Andy Page, right? I've read enough about it to say, all right, I know where I think it applies. But when it comes to saying what's the best resource out there for somebody that wants to learn and make good decisions, I always say, gee, I know a guy you can call. Right.
Yeah. There are tons of books out there, but there's a real challenge with any of the condition monitoring stuff. There's how the data gets to us. There's the analysis of the data. And then there's the kind of the science of condition monitoring, like what you do with the data. And depending on whose book you pick up is which of those three they're kind of focused on. And I'm not aware of a book that equally focuses on all three, or even tries to address all three, because we could spend the rest of the day talking about vibration theory and what all the different frequencies mean, but turning that into useful information that a maintenance manager or a maintenance planner can understand and is actionable by them is literally a whole nother art, right? So, one of the biggest problems we have with vibration analysts is they write up the recommendations as the analysis results and recommendations as if they're talking to another vibration analyst, right, which is a mistake. Because if Ron was our planner and Ron didn't have a vibration background, you grab a standard analyst report and send it to him, and he doesn't have a clue what to do with it. So one of the things, when we talk about route-based vibration analysis and using vibration to drive proactive work, one of the big challenges is in writing it where non-vibration people can understand it and it's actionable. So
Yeah.
Very good.
Does that
I
make
think
sense?
that's really, yes, of course. I mean, I've seen it, time and again. You send it to operations, they pick up the report and they go, oh.
And I don't blame them. I don't blame them a bit. I would say the same thing. If the roles were reversed, I go, look, man, you're gonna have to write this where non-vibration people can understand what you're talking about, right?
Yeah, what's the condition? What's the risk? What do I need to do? What they're really looking for is, what do I need to do?
Right.
And along with maybe some caveats about you might be able to run it for a month, but the risk in that is you're more than likely going to have a failure before that month's over. Now, you don't know for sure, but at least you can give the guy some indication about the risk he's taking if he continues in that mode.
Exactly. But we try not to even get to that situation, right? We if you take the P to F curve and you kind of split it into 5 zones, right? Zone 5 being near to P and zone 1 being near to F, you could relate that to like priority 1 through 5 on the work order system, right?
Yeah. Okay.
So what we try to do is, what we try to teach and coach is find it early, fix it early, because that's the only way to lower maintenance costs. That's the only way to improve availability. It doesn't improve reliability. That's a different story, different calculation, but it improves availability, right? So if we find it early, fix it early. If we find it in zone 5 and get it fixed before it leaves zone 4, now we're doing something. Now we're making a difference. And we never have to worry about, will it run one more month or not? Because we found it, 3-4 months early, right? So, can I get it on next month's down day? Yeah. Problem solved, move on to the next problem, right?
Okay.
We're never in a have-to situation, right?
Yeah. One of the things that I've observed, and it varies from plant to plant, is that some folks will monitor just about everything, and some folks will monitor only when they hear wee wee wee. So, well, it's too damn late at that point. But I digress.
Yeah.
Do you have a particular recommendation, observation, suggestion about if you got, say, 1,000, machines, motor driven or steam driven machines in a plant, should you monitor all of those, 90% of those, only the critical ones? Because you get that question a lot. I'm only going to look at the critical machines. Well, hell, then I'll give you my observation of that. If you only monitor the critical machines, you're living in two worlds. One's a world where it matters and one's a world where it doesn't. Well, people, they have difficulty operating in both those worlds on a day-to-day basis.
Right.
So, what I tend to suggest to folks is you got to have something comprehensive.
Yeah.
Now, based on risk, you may monitor less often or more often, depending on the situation. So just any thoughts about, how you characterize that or how you set up a program for that?
So I'll give you the short, dirty answer first, and then I'll give you what would generally be considered the proper answer, right? So let's just jump to short and dirty. If you're not somewhere in the neighborhood of 75 to 85% of your rotating equipment, then you're not driving enough proactive work with vibration. You're probably wasting most of your time and nearly all your money.
Okay.
So 75 to 85 is just a rough cut, right? There are some industries where it's closer to 92, 93, but there are no industries where it should only be 60 or less. That doesn't exist, okay? So that's the short answer. And how do we know that? Well, here's how we know that. And this is the actual proper answer. This is what we tell people all the time. This business is done at the failure mode level. It's not done at the component level, and it's certainly not done at the equipment level or the system level, right? So whether you run to fail, time-based replacement, or any kind of inspection or post-maintenance inspection, that is a failure mode by failure mode decision, okay? So I want you to picture a group of assets, a group of equipment. And through our criticality analysis, we dropped them into one of 5 categories, right? Most critical, high, low, medium, and not. Okay, so we got 5 groups. For your most critical, at the failure mode level, if there are any applicable inspection methods, I want them all per failure mode, right? So if that's vibration and mechanical ultrasound and mechanical thermography and oil analysis, I want them all, right? So think about, the reason we do that is think about, I need 1 pump, so I'm going to install 2. I need redundancy on this machine because of how important this machine is to the system. It's the same exact concept when we look at inspections versus the failure mode. If it's a critical machine and it has a critical failure mode, then I want redundancy in my inspection methods. It's the N+1. It's the same concept, okay? As I move to the high criticality group, I'll say, okay, give me the 3 best per failure mode. When I go to medium, give me 2 best. When I go to low, give me 1 best. And for not, give me none. Okay? So when you do it that way, and then you back up and run your calculations, you'll find about 85% of the rotating equipment should have vibration applied to it.
Okay.
And you were able to determine that at the level you were supposed to, which is failure mode.
Yeah.
Right.
Well, I don't know if you're familiar with John Schultz's data, where he went out to, 25 plants, 5 different companies, and he's got data on the maintenance cost over time as a function of % of equipment that's under a proper program.
Yeah.
And it shows pretty clearly and across an array of industries that the less you do, the higher your cost, the more you do, the lower your cost.
Mm-hmm.
And I don't know if you actually helped John put that data together, but I use it in my workshops with his permission.
Yeah.
But
it
just demonstrates it.
Yeah, he had that data long before I met him. But I have not found anything that even comes close to refuting those relationships that he discovered in those studies. In fact, all the stuff I found tends to support it very strongly.
Yeah. Well,
One of
and
the struggles
Doug.
that companies have early on when they get into the technologies is just as you talked, if they're looking at their critical assets, they apply everything. They're high critical, they're applying 3 and mediums and so on.
Yeah.
Is they can become overwhelmed with corrective stuff.
Yeah.
Right.
Absolutely.
And so what are your recommendations on how to deal with that? Because there's always that excitement that's let's just jump in and go. Right.
Right. Yeah.
Yep. Yeah. We were doing pretty good till you found all these problems.
Yeah. Right.
Yeah. So I have a story for that, and then we'll answer that question. Years ago, we were monitoring, doing all the condition monitoring for a group of mines and chemical plants. And this particular company bought their local competition. So overnight, the number of plants we were monitoring on doubled, right? So we're hiring people and buying gear and I'm putting the less experienced guys with some of the more experienced guys and redistributing everybody. And it was quite an exciting time. And
yeah, I bet.
We sent I don't want to say his name, but we sent one of our guys down, with some of the lesser experienced guys, and they had all their gear but the vibration gear, right? They had thermography cameras and strobe lights and all kinds of stuff, right? And I said, hey, teach some of these lesser experienced guys what you can find with some of this gear as you go down and introduce yourself to the plant and start understanding where everything is and all that. And I'll be down in a couple of days. I'm bouncing around to these other newer plants. Well, that was on Monday morning. Thursday morning, not the maintenance manager of that plant, but the plant manager of that plant called me and said, you got to tell this guy to stop. And I go, what happened? He goes, since he got here Monday afternoon, he's laid 276 work orders on us. And I said, I understand. I apologize. I'll fix that. Right. So I called this guy up and I said, hey, meet me for lunch. He said, I can't, too busy. And I said, no, it wasn't a question. Right. It was meet me for lunch. Right. So he meets me for lunch and I tell him about the call. And he goes, well, I got 55 more. I'm going to give them after lunch. I go, no, you're not. I go, man, they're new to this. I go, they're barely crawling and you're coming in there at Usain Bolt speed. I go, this is not going to work. You're going to flood the system, right? So Doug, to answer your question, the approach I like to take is I call it a maturity progression approach, right? You've got your criticality analysis, right? So we like everything else, we do it in criticality order, and split your stuff up into 5, 6, 7 groups, however many feel good to you. And with that first group, apply the correct methods, inspection methods, figure out what's wrong, get that group healthy, get your asset health of that group up to about 90% and show that you can hold it for 3 months. When you can show that you can hold it for 3 months, pick up the next group. Now, the collective asset health of the 2 groups now will drop. Get the collective health of both groups up above 90, hold it for 3 months, show that you can sustainable. Okay, then pick up the 3rd group. And this repeats till you've picked up every group. And this is how you respect the criticality, leverage the inspection methods, and don't overwhelm your work execution management system.
There you go.
Now, one thing that probably happens, so you might want to comment on this, is you've got them in buckets of, whatever, 1 through 5. And somewhere as you're working on that group 1 to get those sorted out first, something's going to happen. So I'm assuming you take that and you throw it into the bucket number 1 or another bucket as you progress, because you are going to have other things creep up over time as you're getting through that 3-month period. Is that a fair assessment, or you have another suggestion?
I'm not exactly sure what you meant there. What do you mean something's going to come up?
well, let's say that the guy, your buddy there, he found 5 groups, let's say 500 work orders, 500 jobs, right? And the plant's going crazy and saying, take him away. We were doing good till y'all showed up. So,
Right.
so you've got them now in buckets of 100.
Now, I
and you
wouldn't,
work.
I wouldn't, first of all, I wouldn't let him go find 500 things.
Okay, well, but
Right.
you got my point.
Well, kind of, but we stick with the group 1, and we
Yeah.
would only leverage our inspections on group 1. Group 2, 3, 4, and 5, you'll manage the way you've always managed. We'll
Okay.
get to them in turn.
All right.
Right.
So-
So focus on group 1, get it healthy, and then add group 2 to the mix. Right.
So if something in group 2 gets substantially worse, quickly overnight or whatever, you wouldn't move that up to the group 1.
Nope, you'd manage it the same way you've always managed
Okay.
it.
All right.
And if it got up, if you'd escalated the same way you normally, you would always have escalated. Right.
Okay.
But what I'm just saying is, don't go looking for more problems than you can physically fix.
No.
Because it will only frustrate you, and it will only cause a credibility loss for the program.
Yeah.
So, groups 2 through 5, nothing any different than they have for the last 20 years. Just
Okay.
something to do for group 1. And then when we get them healthy, we'll pull in the next group and start doing them differently. And then so it's not like I'm disregarding groups 2 through 5. There's no change in strategy until we get to them.
Okay.
Yeah.
All right. So in the short term, you're just going to, run to fail or whatever it might be that happens to occur.
Whatever we were normally doing, most people
Yeah.
don't run everything to fail, right?
That's what I hope.
Yeah.
So,
Yeah.
okay. All right. All right.
But and that might sound like a rough method, right? But remember, we did our criticality analysis, and the first group is the most critical, right? And the second group's the second most critical, right? And there may be 6, 4, 10, however many groups we cut it into, but it's always done in criticality order.
All right. And you always try to limit it to what you can actually handle in that time frame.
Yeah, well, that's one of the choices you have to make is how long do I get to get this group healthy? And anything more than about 90 days, you probably chose too large a group.
Okay. Yeah.
Right.
You want the results to come fairly quickly. Otherwise, people get impatient and they lose confidence, and
That's it.
you get an emotional issue going on there. So, okay. All right. Now,
Which, by the way, you and Ron, you and I have talked about a lot about criticality in doing this, but it also comes into play here with being smart with that. There's that temptation to say, gee, my CMMS only accepts 5 categories. So we got A, B, C, D, E, and F, right? Or 1, 2, 3, 4, 5. And that's my only categories for ranking. Well, if you got 10,000 assets in 5 categories, right? That's still a whole bunch of stuff in there, right? And so you sometimes have to say, all right, so let's make your ranking the square root of how many assets you have, right? And when it comes to putting it into your tool, we'll figure that out, but we still have to be able to manage this process of bringing PDM online, right? And having those 5 categories that you're stuck with may give you too much work. So now we're going to use that ranking that we used with those numbers to make that manageable. And this is the thing, people, take your time, talk to somebody that's been there, done that, get some good advice before you jump in. Otherwise, you end up, and this is the problem with criticality. We've already done that 3 times. Well, you did it wrong 3 times. Right. And it's hard to say.
Yeah, we could do a whole nother podcast just on criticality analysis.
Yeah, absolutely.
put that on your list there, Kim.
So, Andy, the next one that I get quite a bit is how often, right? I realize that's based on the PF curve, but is it monthly? Is it quarterly? Is it semi-annual? And
Yeah. So
You get the financial piece that comes along with that as well, right?
yeah. Well, the funny thing is, if you look at, if let's just take a regular, mechanic dedicated to PM, and we look at what they cost versus how many inspections they can do per month versus how many work orders they produce. And I'm talking about a good mechanic with a well-designed PM program.
Mm-hmm.
And then you take a PDM technician with how many inspections they can do per month versus how many work orders they produce per month. So if you take dollars per work order compared to dollars per work order, PDM is by far the cheapest inspection strategy you can do. Now,
And
not
sorry,
every,
you also get more accurate information, more comprehensive information.
Yeah.
It's way more accurate. But that's what I was going to get to is not every inspection can be replaced with PDM, but those that can be replaced by PDM, your event horizon, right? The length of time you have between identification and potential for functional failure is 2 to 4x what it would be with just walking out there and using traditional tools and your human senses, right? So the length of time that you have for your planning and scheduling processes to work is substantially longer, right? So when you lay in quality on top of cost per inspection, it's not even the same sport anymore. It's not even close. Now, to your question of time, Doug, ARMS technology, there is, I think ARMS bottom, but there's a piece of software out there called Availability Workbench, which is used to model all of these things. And it's kind of a third tier, EMP optimization tool. But years ago, we modeled out this exact thing, right? We took a regular AC induction motor. We took the top 10 failure modes for the motor. We took a kind of a nominal amount of, value per downtime. And then we modeled out allowing these failure modes to run to fail versus identifying them with vibration and what that would look like. And one of the great functions within that tool is an optimization circuit that will calculate for you the optimum interval for inspections based on the failure data you put in and a few other characteristics that you programmed in there. And strangely enough, it came out to 35 days for vibration. So when you back that up to 28, just for convenience sake, because 35 days is a very difficult thing to manage, right? But 28 days is very easy to manage. I think your cost went up a few pittance of a percent, not even a whole percent, right? So those studies are available out there, but the short answer is monthly. Unless you've got a failure mode that has two characteristics. A, is dominant, and B, the P to F interval is, say less than a month, which is very odd, but they do occur, right? Especially on high-speed centrifugal compressors and that kind of thing, right? So where you've got that, the answer then is continuous monitoring. Wire some sensors up, pull it back to a control panel, hook it to your DCS, and use it as a kill switch, not as a condition monitoring tool, but it doubles as a condition monitoring tool as well.
Okay. I had a question about contracting.
Okay.
Now, this may be near and dear to your heart, but
not really.
but when folks ask me, should I or should I not contract it? We just give you some broad suggestions that I make to people, and then you can jump in and correct me or modify what I say. In my view, if you're a big company, an Alcoa or a DuPont or somebody that's big, huge, and you've got lots of resources, I think your condition monitoring program, by and large, should be internal. with bringing in experts like you as needed to help you refine and do some particular difficult problem solving. The smaller you get, I think the more likely it is you're going to be better off to contract it out. And somewhere in the middle, you know, my view, and we could talk about what that means, but you should do your own vibration, but probably contract out things like infrared, you know, things you don't do very often, but they're really important to you in terms of consequence if you miss something. So yes, those are just general comments, and I could refine those, but we don't have a whole lot of time. So let me just bounce that back to you and see if you had some suggestions on that.
Well, on the really small stuff, I totally agree, because it just becomes a function of scale, right? When you've only got 6 or 8 mechanics and 2 electricians, you know, dedicating one of them or hiring a dedicated person to do condition monitoring doesn't make a whole lot of sense.
Right.
But for the middles and even the larges, it has, in my experience, it has more to do with culture than it does finances. You know,
Yeah.
and I won't name them, but it's been very clear to me over the last 20 years that there are certain industries that rarely look outside their walls for help. There are other industries that often look outside their walls for help, right?
Mm-hmm.
So I've been to some places where it's unusual to see a contract of anybody in there doing anything, unless it's construction, right? So once they get in operation, consultants and contractors are very rare to see. They're very proud of doing it themselves. They're very suspect of things that existed outside their walls, right? And then there are other industries where the exact opposite is true. So for me, it's more about the culture that exists and whether or not using contractors is part of their default thinking, part of their business model or not.
Yeah.
And where it's just everyday occurrence for them, contractors is probably a great answer. But where it's not, then in-house is almost the only answer, right?
Yeah.
So it's more about culture than it is about money.
Yeah, and I would agree with you because I've kind of like you, I've been in companies where they kind of insist on lots of internal stuff, and I've been in other companies where they insist on none of that. You know, we're going to contract all of it because they don't, and it's a it's really a CFO kind of issue. The CFO doesn't want direct hires on the payroll in a lot of cases, so they'll contract before because they feel like they have more control or more leverage or more whatever. And I don't really fully appreciate or understand their position, but it's well, it is what it is, and you just have to deal with it.
Right.
And, okay. Yeah. And I've also seen some companies, you know, they, you know, years ago, DuPont did most everything internally. And I think it sort of drifted away from that with the advent of new CEOs or new CFOs or that sort of thing. And I think to their detriment, and I don't know that, you know, absolutely, but just anecdotally.
Well, it's also as a function of acquisition, right? Big companies buy other big companies that have a very different culture. And then those cultures start getting mixed and then things change.
Yeah. But I guess the broader point I would try to make here is that you really need a comprehensive condition mining program because 90% of your equipment has a random failure pattern associated with it. And therefore you better get on top of, you know, checking out all those random failures in sufficient time to either avoid or mitigate the consequence of that failure.
Yeah, definitely, right? You know, 90% of the failure modes of all my equipment is not an interval-based replacement kind of strategy, right? So it becomes either a route-based inspection or a post-maintenance inspection, right? And vibration and many other inspection methods, but vibration in particular, are very effective for both of those.
Yeah. Now, one thing we hadn't touched on, we're starting to run out of time. So let me just throw this out there and you know, and then I'll let Doug or whatever, and that is commissioning. And, you know, I'm a strong believer in commissioning because as you would know, both of you would know better than I do that, something on the order of 2/3 of equipment has this infant mortality, failure pattern, and therefore having proper installation, startup, and commissioning, which I think is often kind of lax. They do the installation, they do the startup, but then the checking on whether or not you did it right is usually, well, it's running good. And nobody actually looks in with any kind of a comprehensive approach.
Yeah.
So do you have any comments on that?
Oh, absolutely. I've been using the phrase post-maintenance inspection because we'll only install it once, but we'll maintain it hundreds of times before we do something with it, right? So
Yeah.
Only difference between commissioning and post-maintenance is commissioning was the first one. Post-maintenance is all the hundreds after that, right? So there's really no difference. So if you've touched it with tools, you need to check it before you hand it over to operations.
Yeah.
So, whether it's the first time or the 25th time, doesn't matter.
Yeah.
Right?
Well, I only in that there are some things that you pick up on commissioning that if you don't deal with it before you actually start, you might be living with that for a long time. Right.
Well, I
And
granted
you'll
that,
see that.
yeah.
And that's why I really push on companies to say, hey, if you got a project going on, you need to consider your PDM stuff right up front, and get that stuff done as part of your startup. So you actually have a baseline and you resolve those things that you might end up living with for 10, 20 years if you don't pick them up.
Yeah. So
like that soft foot you mentioned earlier.
You and I are saying the same thing, Doug, but the only difference on commissioning is you can get the installation contractor to fix it on their nickel.
Yeah.
Before the procurement person has signed off, the final sign off, and now it's a new PO, right? That's the only difference. But it's still people touched it. So did you check it after somebody touched it? And now touching may have been the first one or the 25th one, doesn't matter, right? But you're just talking about who's paying the bill, right?
Absolutely.
Right.
Doc Palmer, I don't know if you've seen Doc Palmer's statement, but Doc Palmer says 30% of the time you work on something, you're liable to break it. So now I don't know if it's 15 or 45, but it's a pretty significant period of time. And those B-24 bombers illustrated that, profoundly. So, all right.
I don't know what the number is, but it's more than enough to justify proper, post-maintenance inspection.
Absolutely.
Right.
Yeah.
All right, gentlemen.
A minute or so left. Any final closing comments from anybody?
Yeah, I would just say that whether we're talking about vibration or any of the other, condition monitoring technologies, or even non-destructive testing technologies for that matter, if you're not thinking of it as I can use this to drive proactive work, then you should reevaluate what you're thinking of it, because well and truly that's where the value is, right? Driving proactive work, helping us identify and eliminate as many failure modes as we possibly can, and for those we can eliminate, at least find them early, fix them early, right? So it should be all about driving proactive work.
Yeah, and I agree with that. All right. I reckon we're just about wrapped up here. Kim, do you want to jump in and close us out?
Yes, well, great. Thank you guys today for your awesome session on behalf
and thank you,
of the
Andy, for
entire
coming.
team. Yes, thank you so much, Andy, for joining us. On behalf of the entire team here at Mobius Connect, thank you to our wonderful audience for joining us today, too. Just a quick reminder, you can see past episodes of Connect Conversations on YouTube by searching Mobius Connect or on Reliability Connect. Be on the lookout that episodes typically air every other Tuesday at 2 p.m. Our next Connect Conversations is actually next Tuesday, and it is a case study designing for reliability. If you are interested in engaging with other industry professionals or would like to participate in the industry's live feed and forums on Mobius Connect, You can visit mobiusconnect.com to create your free profile. Be sure to also follow us on social media at Mobius Connect to stay up to date with the latest community happenings. If you do have any questions at all, you can email any of us here, but also our team at info@mobiusconnect.com. Thanks again for joining us. Have a great day, and we hope to see you next Tuesday.